Alright, today's lesson is going to be over circumference and arc length. We know that angles can make intercepted arcs, and we know how to find the circumference of a circle, but how do we use these things that we already know to find the length of a portion or an arc of the circle? So as a refresher, let's talk about circumference. Remember that circumference is either 2 pi r or pi times d, and those formulas are given to you on the formula sheet. So what I'd like for you to do is take some time and do these practice examples shown here. Go ahead and pause the video and give it a shot. For number 1, we were asked to find the circumference given a diameter of 16. So the circumference is either 2 pi r or pi times d. Since we're given diameter, I'll plug in 16 into d, and I'll get pi times 16, which is 16 pi inches. That would be the circumference for number 1. For number 2, you are actually given the circumference and asked to find the radius. So circumference equals 2 pi r. Circumference is 35. So now it's our job to solve for r. So divide both sides by 2 pi. Now if you're putting this in your calculator with the divide button, make sure you put parentheses around the 2 pi. The 2's and the pi's simplify to 1, so I'm left with r on this side equals, and 35 over 2 pi is 5.6 yards. 0.6 yards. There we go. Alright, so what we know is that the whole circle is 2 pi r. That is the circumference of the circle. But what happens if I only want to know a portion of the circle? Well, we know that a circle has a measure of 360 degrees. And if I were to create the central angle here, let's call it ACB, that this angle, whatever it is going to be equal to the arc measure here. So instead of having the whole circle 360, I have, let's say, 60 degrees of it. So what you would do is you would write 60 over 360, because that is the fraction of what you would have, times whatever the circumference is of the circle. So you see I have 2 pi r shown here, but you also must multiply it by the measure of arc AB, so whatever degrees that is, divided by 360, which is the total. So if you have 90 over 360, you know that 90 degrees is 1/4 of 360. 90 over 360 is 1/4. Okay, so just keep that in mind as we work forward. Now remember that the arc measure is actually in degrees, and the length of an arc is in linear units. So if I ask you for the measure of arc AB, that's different than asking for the length of AB. Okay, so measure degrees, length is in linear units like centimeters, miles, inches, feet, etc. Alright, so let's go ahead and put that into practice. I want you to find the length of arc AB. So remember that I would need to first find the circumference of the whole circle. So the circumference of the whole circle is 2 pi r, with r being 5. So the circumference would be 10 pi centimeters. Now, I only want 50 degrees of the total 360 because the central angle is 50. That means arc AB's measure must be 50 degrees as well. So instead of the whole 360, I only want 50 out of the 360 degrees I'm allowed to have. So I will take this fraction and multiply it to the circumference of the whole circle, 10 pi. So if I type this in my calculator, 25 pi over 18, or since I did not tell you to round or leave in terms of pi, I'll give you both answers. 25 pi over 18 or 4.4. So what I'd like for you to do is go ahead and pause and try these two problems here. So to find the length of AB, I would first do circumference. So 2 pi r, and that's 15 for the radius. So 30 pi feet. That's the circumference of the circle. Now, I only want 90 degrees out of the total 360, so 90 over 360 times the total circumference of 30 pi is 15 pi over 2, or an approximation of that would be 23.6 feet. Okay? Alright, so let's take a look at the next one. The next one, it says I want you to find the arc of AB. So I'm given a diameter of 34, so circumference, I can use the formula for pi times d. So circumference equals 34 pi centimeters. And I only want 150 out of the total 360. So you do 150 out of 360 times, times the 34 pi. And that will give me 85 pi over 6, which is approximately 44.5 centimeters. So that right there. Now in the past we have learned how to go from circumference to radius. So in the practice problems I had you do in the very beginning, I gave you the circumference of 35 and asked you to find the radius. Now in this case, I'm giving you the arc length, which is 3.82 meters. I'm giving you the arc's angle of 60 degrees, and I'm asking you to find the circumference. So, remember that the formula is 60 over 360, it's the measure of the angle over 360, times 2 pi r equals the arc length, so 3.82. Now here's the cool thing, this 2 pi r is circumference. So what I'm going to do is, in replacing the 2 pi r, I'm going to put a big C there, because my goal is to solve for C. If I was going to solve for radius, I would leave it in terms of 2 pi r. So what I'm doing now is 60 over 360 is being multiplied to C. So let's divide each side by 60 over 360. Alright? So that simplifies to 1. The circumference here has to be 3.82 divided by 60 over 360, 22.9 meters is the circumference of this circle. Alright, in this case I'm asking you to find the central angle. I've given you the radius and I've given you the arc length. So the arc length is equal to the angle over 360 times 2 pi r. Notice that I plugged in 55 for r, I plugged in 35 for the arc length, but I plugged in the variable, just any one I wanted, x, for the angle measure. So now it's our job to solve for x. The first thing I'm going to do is I'm going to simplify all of this right here. So 2 times 55 is 110 pi. So we have x over 360 times 110 pi equals 35. So let's go ahead and divide this 110 pi from both sides. Because it's being multiplied, I can say those will reduce to 1, and 35 over 110 pi, make sure you put that in parentheses, get a small number, 0.1012. Equals x over 360. Now, x is being divided by 360, so we must multiply both sides by 360. So I just type answer times 360. X equals 36.4 degrees. And that's it. Alright, so in this one, we're asked to find the radius of the circle. We know the arc length is 35. We're given the angle measure of 40 degrees. And then we are asked to find r, the radius. So now it's our job to figure out what we're going to do. Alright, here's how I like to work the problem. I actually like to work it like this. Solve for C. Solve for circumference. So I would then divide both sides by 40 over 360. And I get 315 centimeters equals C. Now I know that C is really 2 pi r. So now what I'll do is I'll divide by 2 pi from both sides, and make sure you put the bottom in parentheses so that you get r equals 50.1 centimeters as my units. Alright, so why don't you pause and give these two you-try questions a shot. Alright, so hopefully you are unpausing the video and looking to see how we solved. Now we're looking for the measure of AB. Remember, that's going to be the angle measure. So 18.84 equals x over 360 times 2 times pi times r. So I'm going to simplify this to be 18 pi equals 18.84. Then let's go ahead and divide both sides by 18 pi. Oops, I'm running out a little bit of a slide down here. Alright, so I get 0.33 equals x over 360. I simply multiply what I have by 360, and x is 119 degrees. Alright, for question number 8, it says find the radius. So I know the arc length is 1.57 equals, and the angle is 45. And I'm going to make it times c and then go back and divide by 2 pi to find the r. So by dividing both sides by 45 over 360, I get 12.56 as my circumference. And since I know that circumference is really 2 pi r, I can plug that in and divide by 2 pi on both sides. So r will be equal to 2 feet. If you did not get 2, you need to double check. You can use the N over D button in your calculator, or make sure you put parentheses around your 2 pi. Alright, so before we leave for today, I'd like for you to notice that a semicircle is actually half of the arc length. So let's say that the circumference of the whole circle was 20 pi, then the semicircle would be half, or 10 pi. Now in the case of 90 degrees, if the whole circle is 20 pi, I would divide that by 4 to get 5 pi, because 90 is 1/4 of the circumference. So these are just some observations, maybe some shortcuts that you can use in the future if you notice that you have 180 degrees or 90 degrees. That's it for today. I'll see you guys later.